Hello everyone. In this presentation, we will present AutoNLU. This is the work done by Nhâm Lê, Tuấn Lại, Trung Bùi, Du Xuân Kim at Adobe Research. So let's start with asking the question, why are we doing this? So at Adobe Research, we need a framework for product teams to train NLU components. And at the same time, we need a framework for research teams to train and test their own NLU models. And are we reinventing the wheel? So why not just use Google AutoML, ML, Dialogflow, or Microsoft LUIS? And the answer is, in those platforms, we have no control over which algorithm to use, no control over our datasets in the sense that we have no idea if our dataset will be safe. And we also have no control over trained models. So we cannot just go to the service and download the trained models for future use. And why not go with Rasa or Rasa X? And the problem with Rasa and Rasa X is that from research standpoint, they only support model that implemented using Rasa API. And here we introduce AutoNLU, an on-demand cloud-based platform with an easy-to-use interface that helps product teams and research teams to train and develop NLU components. And here is the main architecture. So as we can see, we have three main components. The first one is a web application. Second one is a cloud storage system. And the third one is an on-demand cluster. Note that we are cloud agnostic, so each of these components could rely on Microsoft Azure or Amazon Web Service or Google Cloud Service. Let's talk about the first component in the system, which is the web application. And this is how the end users will interact with AutoNLU. At the heart of the web application is the scheduler, and the scheduler will monitor the status of the cluster, assigns jobs to the instances in the on-demand cluster, and spawns or shuts off instances based on the workload so that we can have the minimum amount of worker at every single time. The second component in our system is the cloud storage system that hosts the datasets and the trained models. So note that we decouple the storage system from the cluster because we want to host the same dataset for multiple worker instances, and we also want to host the same trained models for multiple worker instances so that during training, the worker can download the dataset from the storage system, and after training, it can upload the trained model to the storage system. During testing, the model is downloaded from the CSS to the instance so that the instance doesn't have to include the weight itself. The final component in our system is the on-demand cluster that does the actual training and inferencing, and instances in the on-demand cluster could be created manually by a user or automatically by the scheduler. Next, we will take a closer look into each worker in the cluster. Each instance is created using a Docker image, and in this Docker image, we put the code to train and run the models. Note that compared to Rasa X, model could be implemented using any language as long as they provide a COI so that we can run the training and the testing from the command line. And by default, workers are initiated using an image that has all supported models. Of course, we also have smaller images that has only a single model inside. So it's really up to the end user and the scheduler to manage the instances. As promised in the introduction, we also provide an easy-to-use interface for not just product teams to train the models, but also for the research teams to develop the new algorithm and test their algorithm using the available dataset inside Adobe. Concretely, we provide the Dataset Tool, the Analysis Tool, and the Resource Management Tool. First, the Dataset Tool. Inspired by Rasa and the works in the compiler community, we create an intermediate representation for all the dataset format. So any dataset format can be converted into the intermediate representation, and from the intermediate representation it can be converted to any other different dataset format. As the consequences, it is relatively easy for us to provide a very useful user interface for editing, adding, and managing dataset, as you can see in the screenshot. In here you can see sentences with entities that are color highlighted. User can easily add more example or modify an existing example, and they can immediately see the result of their editing in the interface. We also provide many analysis tools for the end user, and in here I want to talk about an interactive confusion matrix that proved to be very useful for our product team. So after training, normally you can have a confusion matrix, but that itself is not really useful. But we provide the functionality in which user can click on any of the cell in the confusion matrix and see clearly which instances are misclassified. This is very useful in practice because in many cases the problem is not really in the model itself, but actually in the dataset. So by looking into this view, the product teams can go back and fix the label in the dataset. Finally, I want to talk about the resource management tool in AutoNLU. In this view, user can create more instances and have an overview about the status of the whole cluster. Why do we allow user to create their own instance? This is because sometimes you know more than the system about your use case. So if you just want a very lightweight instance to test a small models, then you don't need a GPU at all, and you can do it yourself, and that would be more efficient. In this final section, I want to talk about two successful case studies inside Adobe. The first one is training and cleaning dataset for the Photoshop Creative Assistant project. We have collected and labeled the dataset for this project over a long period of time, and there's a certain amount of labeling errors inside the dataset. Utilizing the analysis tool, we were able to train and clean dataset at the same time and ends up with a usable models that currently being tested for the Photoshop Creative Assistant. For the second use case, I want to talk about training a key phrase extraction model for the document cloud team inside Adobe. For this problem, we simply rephrase it into a tagging problem and write a converter to convert existing dataset into our intermediate representation and just train a provided model. Using AutoNLU, we were able to have a usable model for key phrase extraction in very short amount of time. More details about our work could be found in our paper. Thank you for joining us in this presentation.